So last time we looked at factorising and we've looked at the formula. Now we're going to look at completing the square. So it's an algebraic method of putting the equation into that form to solve it. The first example, we're going to have an expression and it's asking us to complete the square on the expression. So we've got x squared minus 6x minus 5. And we need to put that into that form with a x minus p all squared plus q. Because we've only got one x squared, there's going to be no number in front of the brackets. Then we consider this minus 6x. That minus 6 gets halved, so inside the brackets we write minus 3. At the front of the brackets we just write a single x. Now if we multiplied out those brackets, we'd have x squared minus 6x plus 9, because that minus 3 squared makes a 9. So now we're going to take away that additional 9 that we didn't start with. We had a minus 5 in the first line, so we're just going to write that again. Now all that's left to do is to simplify. So we're just going to write our x minus 3 all squared in the brackets, and then we've got minus 9 minus 5 gives us minus 14. So if we had to state our p and q values, that would be our minus 3 and minus 14. Now we're going to use these to state some special points of this quadratic expression. So the minimum point is at 3 minus 14. So we don't use the sign inside the brackets, but we do use it outside the brackets. And it has symmetry about the line x equals 3. The next thing we're going to be asked to do in this question is to solve. Now because this question uses the word hence, we are going to have to use what we've previously done. We write our x minus 3 all squared minus 14 and make it equal to 0. We then have to take over our 14 first. So the 14 moves over to the right hand side. Once we've done that, we're then going to square root it. And at A level, you need to be very careful that you state it has both positive and negative solutions. And then all that's left to do is to move the 3 across. So we end up getting x equals 3 plus or minus root 14. And that's the exact solution that you'd leave.